Question 9. Okay, on to the similarity and prop theorem. Okay, so 9.1. Okay, so in the diagram, ABCD is a parallelogram, very important, with AB equaling 14 units. So let's put our information in. So that's 14. AD is produced to E such that AD to DE has a ratio of 4:3. EB intersects DC in F, and EB is equal to 21 units. So this whole thing here is 21. Okay. We also know that AD is to DE. AD is to DE, so this would be 4x and 3x. Okay, so remember guys, when putting a ratio into your drawing, remember the ratio given to you is always simplified. So we cannot assume that the length of AD is 4 units and the length of ED is 3 units. It will be a ratio. A simplified ratio means that it is 4 times whatever the value is, x. So just remember that it's not the actual lengths, it's a ratio of the lengths, and that's always simplified, okay? So calculate with reasons the length of FB. Okay, so FB, we have 21, we have 14. So do you agree? We can use prop theorem here. So 9.1, EF over FB is equal to ED over DA or AD. And that's because of prop theorem, and that's because DF is parallel to AB. So therefore, EF is to FB will have a 3:4 ratio as well. So that means that 21 will be broken up into 3:4. So 3x plus, well, here we can state that, and we're putting this in now. EF is going to be 3y. It's a different variable because it's a different side, and that's 4y. So we can therefore say that 3y plus 4y equals 21. Therefore, 7y equals 21. Therefore, y is equal to 3. So from that statement, we can then say that therefore FB equals 4 times 3, which is going to be 12 units. Okay, so that was just using prop theorem in order to get that answer. Okay, next, 9.2. Prove with reasons that triangle EDF is similar to triangle EAB. Okay, so next is going to be, let's highlight our triangle, shall we? So we're trying to prove that EDF is similar to triangle EAB. EAB. Okay, so we just need to state our reasons why. So for 9.2, in triangle EDF and triangle EAB. Number 1, angle E is equal to angle E. Reason, common angle. Number 2, angle D in the small triangle is equal to angle A in the big triangle. Reason, corresponding angles. And that's because DF is parallel to AB. And then your third angle in similarity will always be equal. So F in the small triangle is equal to angle B in the big triangle. And that's always because of some angles in triangle. Okay, therefore, triangle EDF is similar to triangle EAB. Reason, angle, angle, angle. Okay, then it says 9.3, calculate with reasons the length of FC. Okay, so do we agree? The information given to us earlier was that this was a parallelogram, which means that this distance here is 14. opposite sides in a parallelogram. Let's put that in. So we're going to say DC equals AB, which equals 14 units. Reason, op sides in palm equal. Okay. After that, we can then state that our similar triangles, so we can state that, and this is what I love doing, and this is the method that I like doing, is that I'm going to draw out my triangles and then my ratio of sides. Because we've proven these two triangles are similar, everybody, it means that their sides are also going to be in proportion. So I'm going to draw the small triangle, which looks like that. E, D, F. And then I'm just going to draw an enlarged version of that triangle. And angle E, now, the way I label this triangle, everybody, is according to my answers here. So the small triangle's angles were all here. So angle E in the small triangle equaled angle E in the big triangle. So E would go in the same position as E. Angle D equaled angle A, and angle F equaled angle B. Very important how you label your second triangle, everybody. If you don't do it properly, you aren't going to get your ratios correct. And then I do big side of a big side, small side of a small side, medium side of a medium side. So let's give these values as well. So we know that ED is 3x. We know that EF is 3y. We know that DF, well, we actually know what y is. Y is 3, so that's going to give me 9. DF, we don't know. EA, we know is 7x. And we know that EB is 21. And AB, we know is 14. Okay, so actually wouldn't be such a bad thing to be able to get DF here, because DF is the important part, because that'll then help us get FC. So if I go red over red, so if I take 9, or let's do it like this, EF over EB is equal to DF over AB. And I'm going to take that from the similar triangles I proved earlier. So triangle EDF is similar, that's where I'm getting this ratio from, to triangle EAB. Okay, so therefore, EF, that's going to be 9 over EB. 9 over EB, which is 21, equals DF, which is what I'm trying to solve for, over 14. So therefore, 9 times 14 equals 21 DF. Therefore, or actually we didn't, therefore, divide both sides. So 9 times 14 all over 21 equals DF. Let's have a look. So therefore, DF equals 9 times 14 all over 21, and that's 6 units. So now that we have DF, we can now minus that from DC to get FC. Okay, so FC equals 14 minus 6, which equals 8 units. Okay, not too bad, question 9. A bit of prop theorem, a bit of properties of quadrilaterals, and some similarity as well. Okay, on to the next one.